So as Wayne mentioned, my name's Andrea Yee. I'm a project manager at WSP. This is my colleague Nastassja Pearson. We're both engineers who work in both new and existing construction, and we're here to talk about enclosure commissioning. So just a quick overview of what I plan to talk to you about today. I'm going to talk about some challenges in building enclosure design. I'll explain what enclosure commissioning is. I'll talk about the benefits and shortcomings of enclosure commissioning, as well as enclosure engineering and enclosure consulting, and I'll differentiate between the three later on. And I'll talk about the true costs of enclosure commissioning as well. So before I dive too deep into the whole commissioning process or enclosure commissioning process, I think it's important to talk about some of the terms that get used and get thrown out there. So building envelope, building enclosure, cladding, facade, skin are all terms that get used in our industry, sometimes interchangeably, and some people might think they mean the same thing, but to us they have slightly different meaning. It's like saying football and soccer are the same thing. To some people in parts of the world, they may mean the same thing, but here in our part of the world, they have slightly different meaning. So building envelope and building enclosure, those terms are very similar and are used to describe the separation between a conditioned space and an unconditioned space. Building envelope typically refers to the portion of the building enclosure which contains the control layers such as the weather barrier, the air barrier, or the thermal barrier. But it's important to note that those layers aren't necessarily going to be in the same place. Sometimes the weather barrier may be located in a slightly different location as the air barrier or the thermal barrier, such as in an attic space where the weather barrier might be on the inside and the air and thermal barrier might be closer to the the weather barrier is on the outside and the air and thermal barrier is closer to the inside. And the building enclosure and the building envelope not only contains just the walls, which is the first thing that typically comes to mind, but it also includes the roofs, it includes the foundation walls, includes the slabs on grade as well. So building enclosure is a slightly more broader term. I know that building enclosure and building envelope get used interchangeably quite frequently. They are very similar terms, but building enclosure tends to be used in a more broader sense in that not only are we really talking about the control layers, we're also talking about things that affect aesthetics. It affects the separation for fire. It affects things like security as well. And then cladding, skin, facade, those three terms are very similar terms as well to each other. And those are more used to describe wall systems. So no longer are we talking about walls and foundations and roofs. We're talking about wall systems. So cladding, the cladding system is a skin or a layer or materials that get added to the building enclosure to help control or protect from the elements. The cladding isn't necessarily a waterproof layer. It can potentially just control one of the elements that we're talking about. It can potentially just control sun exposure, or it can potentially just only shed water. But it is one of those layers that get added to the building enclosure. And then facade traditionally was used to describe the front elevation of the building, but now we kind of just use it to describe one wall or one side of the building. So why does building envelope or building enclosure matter? Why do we have a whole field dedicated to it? Why do we have a whole commissioning process dedicated specifically for building envelope and building enclosure? So the building envelope and building enclosure plays a pretty important role in building design. The building envelope protects us from sun exposure. It protects us from rain, snow, heat, cold, wind, noise, dust, debris, the list goes on. It helps regulate temperature differences from inside to out. It helps regulate relative humidity changes from inside to out, and pressure differences. I can't remember if I mentioned that already. It contributes to occupant comfort. It helps control lighting into the building. It helps provide durability for the overall building. It protects all the elements inside the building such as the interior finishes and the structure, from everything outside. So if you think about it that way, the building envelope or building enclosure is doing a lot of the heavy lifting when it comes to performance for building design. And that's why building envelope matters. So this picture here looks like a pretty great place to live at first glance. It's a penthouse space in a high-rise condo building with floor-to-ceiling glass, wide open space, lots of light. But if you look at more carefully or closely, or if you think about it, it may not be the most comfortable place to live. We know that window wall systems and curtain wall systems don't perform thermally as well as, opaque wall systems, which tend to have a higher R value. So standing next to a full floor-to-ceiling window wall system is not going to be as comfortable as standing next to like a brick or stone wall. Because of the wide open space, it may take a bit more energy to condition the space. And then there's also things to consider like daylighting. Even though it lets a lot of great light in, during those bright sunny days, you might actually get too much light. There's such thing as too much of a good thing, right? And during those bright sunny days, we have a tendency to close the blinds, or at least partially close the blinds to shade us from that light. So you kind of lose some of that vision area, and then you start thinking about the reasons why you had floor-to-ceiling window wall in the first place. And then other things to consider are the shapes and the configuration of the building. So I think most of you are probably familiar with this building. It's one of the Marilyn Monroe Towers in Mississauga. It's got a very unique shape and identity and configuration, but it may be a little bit uncomfortable to stand next to the window wall systems with those continuous concrete balconies around the full perimeter. Unlike Europe, builders here in North America don't tend to use thermal breaks between the outside concrete and the inside concrete, which means those balcony slabs act as large radiator fins, essentially allowing heat loss through the slabs. And because of the unique shape of the building, the round floor footprint, it may be difficult to access in the future. We're using straight suspended access stages to access the building if we ever need to do concrete work or railing work in the future. So it could be potentially difficult to access this building in the future, and it's slightly more costly potentially to perform those repairs. So the reason why we bring these things up is because it's just things to think about when it comes to building design. It may look really great from the outside. I can't argue that this building looks fantastic from the outside, but equal thought needs to be put towards some of these challenges that we may face in the future, such as future maintenance, and then also the comfort for the residents and or the tenants in the building. And while the primary focus of today's presentation is going to be on building envelope and building enclosure, it's important not to ignore HVAC systems. So HVAC design or mechanical design really should go hand in hand with building envelope design. The two really work together when it comes to performance in building construction. Good mechanical design should consider what or how the building envelope is going to perform, and the building envelope should consider what the mechanical systems are going to supply to the building and how they're going to operate. We've heard this really great analogy that I'm going to steal right now, and basically it says that good mechanical design in a building without a good building envelope is like blowing up a balloon with a hole in it, right? You can blow air into the balloon, but if it's got a hole in it, the air is not going to stay in there for very long. So similarly, in a building, if you have a super efficient mechanical system with a poor building envelope, right, you're gonna be able to condition the space fairly quickly, but that conditioned air is going to escape from the building just as quickly if you don't have a good building envelope. So it kind of negates some of the benefits of using a great, efficient mechanical system. So the message at the end of the day is that we need a good balance between a good mechanical design and a good envelope design. You need to consider and have them work together. And the reason we bring that up, or the reason why we mention this, is because in the commissioning world, the mechanical and electrical commissioning process is fairly well established, but only recently has the enclosure commissioning process started to gain traction, and we'll explain why that is. But you'd think that because the mechanical systems and envelope systems are fairly well equally important, you would think the commissioning process for enclosure commissioning is just as important as mechanical commissioning, which it hasn't been the case in the past, but we're starting to see that now. So what are some challenges in building enclosure design? Like, these are the reasons why we have a commissioning process in the first place. We face challenges in building construction every day. New challenges are constantly arising, and the commissioning process is intended to help us flag those issues, catch those issues, and prevent them from becoming even bigger issues in the future. And the reason why we're running into more and more challenges is because expectations are changing, right? Way back when, structures were primarily built to provide shelter. Who cares about comfort? Who cares about aesthetics? We just want to be safe within our structure, right? And then later on, we started to think about things like comfort and maybe some aesthetics. So we started to think about the colors of the building. We started to use more than one material. We use windows, we use brick, we use some basic roofing systems, and then we had fairly basic design. So more challenging to deal with than that stone structure that we saw earlier, but still manageable. But now we have a lot more demands for what our building is expected to achieve. You know, it's supposed to have this unique identity and character. You know, in a high-rise building, it's got to look different than the condo next to it. Otherwise, you're not going to be able to sell those condo units. So in order to achieve all that, in addition to building performance and comfort and all of that, we're having to push the envelope and explore different technologies, different materials, different systems. So we come up with, you know, different curtain wall systems. We're coming up with these flashy structural glass systems. We're using precast concrete. We're using stone masonry, composite metal panels, medial walls, different types of roof, and then on the sustainability or green building side, we're starting to push to make sure that we're building in a more sustainable way. So we're introducing, so not only are we introducing all these complex systems, we're also wanting them to be more green as well. And on top of all that, in addition to looking good, we're running into all these more complex configurations and shapes. So we're dealing with more complex systems. We're dealing with much more complex shapes. So it's just becoming much more complicated overall to deal with from a construction and design perspective. And because the complexity of this construction is just continuing to increase, it's the risks associated with those systems is also increasing with it. You know, we have higher risks of water leakage, air leakage, poor energy efficiency, poor material selection, especially because there's so many materials available to us, and it's really difficult, even for us professionals, to keep track of all the new incoming materials and technologies that are coming in. And it's difficult to keep track of what that means in terms of durability down the road. And then we also run into increased construction and repair difficulties. And ultimately, these things lead to things like rework, costly repairs, and failures. We're not dealing with those 90-degree angles anymore. You're not dealing with one wall meeting another wall at a 90 degree. We're dealing with multiple interfaces, multiple systems, multiple varying tolerances for the different types of construction systems, all meeting into one complicated 3D interface, and we're expecting the constructor to build it, absolutely perfectly, and expecting it to perform the same way. So this is why we have the commissioning process and enclosure engineering. We have these processes in place to help assist us in preventing some of those risks that we were talking about. So what is commissioning? So the internet has told us that the term commissioning comes from shipbuilding. When you construct a ship, you want to check and make sure that everything has been built correctly and the systems have been tested to make sure that the ship's not going to sink before we send it out to sail. And so a commissioned ship is one that's gone through that process of verifications and checks to make sure that everything is A-OK, right? Similarly for buildings, same thing. We're going through the process of checking to make sure that everything is A-OK. We want to make sure that it's achieved these milestones. We flagged any issues or problems or deficiencies and making sure that they're being dealt with throughout the entire process and making sure that we're getting what we want. So ASHRAE Guideline 0, which is being replaced with the Standard 202, describes commissioning as a quality-focused process for enhancing the delivery of a project. The process focuses upon verifying and documenting that the facility and all of its systems and assemblies are planned, designed, installed, tested, operated, and maintained to meet the owner's project requirements. So the key words here are the owner's project requirements, which are established. So basically that's the original design intent. We need to come up with what the owner wants, and then we need to verify and check. Verify and check. That's what commissioning is. It's a process to verify and check to make sure that the building has met the owner's project requirements. And then in the building world, there's a couple of types of commissioning. There's building commissioning, there's retro commissioning, and there's recommissioning. So building commissioning applies to new buildings, where we're checking and verifying a new building in construction. And then we have retro commissioning, which deals with an existing building, where we're commissioning a building that's been already built and checking those existing buildings. And then recommissioning is the commissioning process, which applies to a building that's already been previously commissioned, but we want to recommission it again. And the reason why we may want to recommission a building again is because perhaps the use of the building is being changed. We're refitting out a building for a different type of tenant or something like that. That's why we potentially want to recommission a building. So what is enclosure commissioning? So we talked about the general commissioning process. We talked about building commissioning. There's different types of building commissioning. And now we're talking about enclosure commissioning, which is a subset of the two that we were just talking about. So that refers to the commissioning process which only deals with the enclosures, the building enclosure and the building envelope. So that is the process of checking and verifying that the design and the construction is meeting the original project requirements, the original owner's design intent. So that means checking the design documents. It means doing testing during construction to make sure the construction is consistent with the design documents. And enclosure commissioning falls under this broader category of enclosure engineering. So enclosure engineering is at the top, and then we've got enclosure consulting, which is a subset of enclosure engineering. Enclosure consulting is a subset of enclosure engineering. And then enclosure commissioning is also a subset of enclosure engineering as well. So traditionally in the Canadian market in the past, we've primarily seen owners and constructors engage in enclosure consulting services, okay, in the past and up until now, primarily, with various commissioning aspects involved. So there's kind of been this kind of gray area and a bit of overlap in the past in the construction process when it comes to enclosures. But moving forward, the idea is for those to be separate and independent processes. Enclosure commissioning, again, should be a separate process from enclosure consulting. Enclosure consulting is providing various design advice at various stages of the project. They're there to provide support for the construction team or the design team, and enclosure commissioning is providing those verifications and checks or extra set of eyes on the overall process to make sure everything is running smoothly. Enclosure engineering can be part of any of these stages of construction. It can mean involvement during schematic design, such as helping develop the conceptual design for the building. There can be involvement in the design development stage where we start selecting materials to meet the schematic design. There's construction document phase, construction phase, performance measurement and commissioning, and then the occupancy and operations phase. So enclosure engineering can be involved in any of those stages. And if you want to break it down even further, there's various tasks within each of those stages which enclosure engineering gets involved with. An enclosure consultant or commissioning agent may review concept sketches during schematic design. We may review construction documents during the construction phase, or we may review project documentation or warranties in the end stages of the building construction. And the difference between a commissioning agent and a commissioning consultant is the consultant, again, can be retained by the designer or potentially the contractor to help them progress the design or help the contractor execute the design, and to provide that support or design advice throughout various stages. They can help during the design stages, they can help during the construction stages, or even in the later stages when we're dealing with the problems after the fact if they didn't engage an enclosure consultant early on. And the enclosure commissioner, in theory, and I say in theory because there's going to be exceptions to the rules, but in theory, they're supposed to be acting as an independent third party overlooking the overall process. So typically, the enclosure commissioner is intended to be retained directly by the owner, so there's no conflicts of interest, right? The enclosure commissioner is just checking and verifying everything to make sure that it's done correctly. They're not doing the design. They're not the ones who are correcting the issues. The designers and constructors and enclosure consultants are helping to correct those issues. The enclosure commissioner is just flagging any potential issues that they see along the way and making sure that the appropriate people are dealing with it accordingly. So again, a enclosure commissioner is intended to be an independent third party, extra set of eyes on the overall process, and they overlook the entire process. They'll overlook design, they'll overlook construction, and they'll overlook the operations, the overall operations of the building once it's turned over. And the enclosure consultant is typically retained by the designer or can be retained by the constructor and may not be involved until later in the project when problems happen, or they can be involved early on in the design stages only, or they can be involved in the construction phases, or they can be involved in everything. The enclosure consultant works with the design team to develop building enclosure details and performance requirements. They'll review shop drawings. They'll help turn the details into a system for construction, or they'll review the drawings from the contractor to make sure that everything's detailed correctly as per the designer's intent, and they'll provide support and design advice to whoever needs it, or to whoever hires them, sorry. And the enclosure commissioning agent focuses on verifying the owner requirements and that have been communicated to them and making sure it's being implemented. They'll check the submittals, they'll check the mock-ups to make sure that the contractor is interpreting the design correctly. And then they'll also do testing and site reviews to also verify that the construction meets the design intent and also the owner's project requirements. And it's important to note that commissioning is not a replacement for a good design. It's not a substitute for contractor quality control. It's not intended to be just a spray rack test on one window. It's not intended to be something just to say that you've met a LEED prerequisite, which we'll talk about a little bit later. and it's not consulting. Again, in the past, in Canada, there has been kind of overlaps between the consulting and commissioning process. You know, typically you'll see enclosure consultants involved in the construction, and they'll be engaged in various commissioning aspects, but they're not really, they haven't typically in the past, there have been people engaging in building commissioning, enclosure commissioning, but in the past they haven't really been engaging in the full process, which is what we call commissioning. And these are just some of the services that complement enclosure engineering. Even though we keep talking about enclosure engineering during this presentation, it's important to note that the enclosure engineers often rely on input from other disciplines. They'll rely on input from the mechanical consultants. They'll rely on input from the structural engineers, the fire engineers, because often they'll need to work together to make sure that we're not missing anything. Inevitably, we're trying to build a building. We're not trying to build just an enclosure. We're not just trying to build only a structure. We're trying to build a building. We're trying to build something that works all together. So it makes sense that the designers, the engineers, the constructors all work together in order to achieve that goal. So the reason why the enclosure commissioning is becoming more relevant in our market is because of LEED version 4. So LEED version 4, for those of you who aren't familiar, is the latest version of LEED, which is going to come into full effect in October 2016. I believe you can actually apply for LEED version 4 now if you want, but the older version of LEED 2009 is still in effect in Canada, which is easier to achieve, so not many people have been pursuing LEED version 4. So, but it's also important to note that LEED version 4 is in effect in the States. And what LEED version 4 includes is some new requirements for envelope and enclosure commissioning. So in the LEED version 4, there is a basic prerequisite for just general commissioning, some basic general commissioning requirements. So they need to develop an owner project requirements and basis of design, and then they also need to include, envelope and enclosure considerations into those owner project requirements and basis of design. And then on top of that, there's additional optional credits which are available to you if you engage in envelope commissioning. There's various options that you can choose, but enclosure commissioning is one of those options or credits that you can apply for. So we've already seen, our counterparts in the States have already seen many owners engage in the enclosure commissioning process because of the introduction of LEED version 4, and we're expecting to see the same thing here in Canada as LEED version 4 becomes implemented more and more. So just to elaborate on the owner project requirements and basis of design, so this is like the main focus of the commissioning process, or the initial focus of the commissioning process. The owner project requirements, or the OPR, forms the basis of design from which all design, construction, acceptance, and operational decisions are made. So basically it's the goals of the project. This is where you set what the owner wants out of their building. How high does it need to be? What's the location? How do we want it to perform in terms of energy performance? How tolerant are we to water leaks? Just some general goals for the building. And there's some guidelines out there which help you identify some of those targets that you need to identify. And then the basis of design is a slightly more technical document which helps flesh out the owner project requirements. So in the basis of design, or the BOD, this is where we start to identify the various materials and systems which will help us achieve the goals in the owner project requirements. So if we want a good performing building in terms of energy, in the basis of design, we may spell out the different types of materials we're going to use to help achieve that. So we may want to use R40 insulation in our buildings. We may want to use tapered insulation in our roofs to help improve drainage so that we reduce the chance of leakage in our roofs. We may include some calculations in the basis of design to show how we're going to meet certain lighting requirements, etc. The basis of design is a more detailed and fleshed out version or story telling us how we're going to meet those design intents in the OPR. And so, again, in LEED, the basic requirement to achieve LEED is the fundamental commissioning, which is just the general commissioning process, where you develop the OPR and the BOD. But now in LEED version 4, these additional requirements to consider envelope into the owner project requirements. So we're not just looking at mechanical systems or energy performance as we were in the past. We're also now starting to think about enclosure and envelope in the basic requirements for the commissioning process. And then in enhanced commissioning are those optional credits that I was talking about that you can get for enclosure commissioning. And that's where you have the opportunity to engage in enclosure commissioning in order to create a more comprehensive commissioning plan. So on the left here, these are just some of the requirements for the general commissioning process. So as you can see right at the top, the first thing you do is review and help the owner develop that OPR and BOD, help develop and implement that plan. And then if you want those optional credits, that's where you can engage in an envelope commissioning agent to help review contractor submittals, do testing, review manuals, etc., and help prevent those risks that we were talking about when it comes to building envelope design. And in LEED, there are some guidelines in terms of how to engage in the commissioning process. So this description here actually derives from the ASHRAE guidelines. There's the ASHRAE Guideline 0, which is being replaced with the Standard 202, which outlines the overall building commissioning process. So LEED references this document to help commissioning agents understand what kind of scope that they need to engage in. And it serves, the ASHRAE Guideline 0 and the Standard 202 serves as the foundation for the commissioning process for HVAC and building enclosure commissioning. And then there's Guideline 1, which is specifically for HVAC systems. And then there's also a National Institute of Building Sciences Guideline 3, which provides some technical requirements for building enclosure commissioning specifically. And then on top of that, there's also an ASTM E2813, which is also a great standard for enclosure commissioning. So LEED only references the ASHRAE standard, but there are other standards available, and there's more than this actually, that can be used as guidelines for owners when they're trying to request for a proposal or request for a commissioning agent to become engaged in the commissioning process. This gives the commissioning agent guidelines and an understanding of what they need to do, right? If you just tell someone to do the commissioning for them, you know, you're going to get all sorts of scopes and documents from agents if you don't give them clear guidelines on what they need to do. And I'm not going to go into this in too much detail, but Tarion Bulletin 19 is also a well-established process which kind of follows the commissioning process. Unlike enclosure engineering, enclosure commissioning, it deals with the whole building, so not just enclosure. It deals with fire systems, mechanical systems, etc. And that's where the a field review consultant provides an extra layer of quality review to ensure that the intended design is per construction. And then there's Tarion Bulletin 19 has very specific requirements in terms of what needs to be checked and when. So what does enclosure engineering look like? It could be doing thermal scans in the building to check for air leakage. It could be doing site reviews to check for detailing of flashings through the wall or at sills. It could be doing water testing during construction. All these activities are some of the things that enclosure engineers engage with. This is a great photo. The photo on the left is the design intent, or the owner's project requirement, I guess you could say. And the photo on the right could represent what you can get if you don't have the right specialist or right expert involved. So it's important to recognize that you want someone who knows what they're doing to help you execute your design, right? If you have those complex designs that we were talking about, just like this sheep cupcake here, You want someone who knows what they're doing so that you get the photo on the left and not the photo on the right. And the way that a building enclosure commissioning agent or consultant adds value is by reducing those risks for redesign and rework, and they help minimize the costly repairs when the building is turned over. So for a simpler project, there may be a lower level of risk, so it may be easier to deal with, but for complex projects, that's where building enclosure engineers can provide a lot more value in helping reduce those risks, because you have someone who knows what they're doing, someone who's going to help you achieve that photo on the left that we showed earlier and not the photo on the right. And how do we do that? Enclosure engineers will engage in various processes. They'll engage in design review. They'll do mock-ups, laboratory and field testing, QA/QC plans, maintenance plans. It's important to know I'm jumping back and forth between enclosure engineers and commissioning agents because, again, in the past we historically seen the overlap between the consultants and the commissioning agents. So we've seen these people engage, both of them engage in these processes of design review, mock-ups, etc., and testing. And moving forward, it's still the same thing. Each of them can be engaging in these processes as well to help reduce the risks that we're talking about. So enclosure engineers can engage in design review. That's when we encourage people to sit down at a table in the beginning of the project, engage with other consultants, mechanical consultants, the architects, other designers, structural engineers, to make sure that everyone's on the same page, to make sure that we're working together to achieve a cohesive building design. We'll engage in mock-ups to make sure that things are being done as we want them. Our architects are obviously constantly doing these visual mock-ups to make sure that they're getting what they want, and we're not going to discover that the building is red instead of green or is shiny instead of matte. These mock-ups help us prevent those errors, costly errors, from occurring down the road. We'll do lab testing to make sure that the materials are performing as we want them. We want to make sure that we're not running into risks because of poor materials or poor or improper material selection. We'll also do field testing to make sure things in the field are performing as we want them. We want to make sure that what we're constructing in the field is meeting the performance requirements that we spelled out in the specifications and the design documents. We can help engage in QA/QC plan reviews, so we'll do site reviews in the field to make sure that construction is being executed as per the design intent, and we can help develop or review maintenance plans to make sure that the future maintenance of the building is being considered and the design of the building isn't going to incur costly maintenance costs down the road. So we can talk about the true costs. We can talk about the costs of commissioning, enclosure commissioning, but I think it's important to talk more about what value the commissioning process can provide to you, because obviously the commissioning process is an added cost to the overall project. But if you don't engage in an enclosure engineer or consultants for those much more complex projects, you run into those risks of costly rework that we were talking about, which can be much more costly than the actual cost of engaging in a commissioning agent or an enclosure engineer. This building is a good example of a project that we've done in the past. This is the National Music Center in Alberta. The architect had this fantastic, this grand terracotta screen which bridged across the roadway there. And as some people may know, terracotta is a very absorptive material. It likes to suck in water, and in Alberta we got a lot of wet snow and rain, which they experience over there. And so during the design review phases, we flagged a potential risk of that screen, that terracotta screen, developing ice buildup and snow buildup. And so we encourage the building team to engage in some testing to see if our theory was correct. So we did the testing, and we showed that there was an increased risk for ice buildup and snow buildup and freeze thaw. And so we recommended some solutions to deal with it. But had we not caught that during the design review stages, that would have been a huge liability for the building owners, because there would have been a risk of icicles falling onto the roadway below. It's something that nobody had considered, and it's just something that, because we are very familiar with terracotta materials and this type of construction, we were able to flag that and prevent that from being a risk down the road. This is a building at Brock University where a large screen was installed in front of the curtain wall system. So one of the things that we had flagged during the design and construction phase is consideration for future maintenance. We had suggested installing a rail behind the screen so that in the future, if they ever needed to replace the glass in the curtain wall system behind it, that it would be easy to train in rather than try to dismantle the screen or try to crane in a new piece of glass. Of course, they didn't listen to our design advice, and a year later, they had to replace a piece of glass, and they had to get several cranes, several men on site, and they had to dismantle part of the screen just to replace one IGU. Had they installed the design rail as we suggested, we expect the cost would have been a lot less. And now this is an issue that they're potentially going to continually face down the road as they need to replace additional IGUs. This is one of the largest zinc roofs in the world. One of our colleagues had worked on this project, and he had noted during one of his reviews that there was a hole. So we weren't involved in the design aspects of this roof, but during the reviews he noted there was some holes in the zinc roof, and what he noted was there was actually a reverse seam, or the seams were reversed everywhere. So typically you'd want the seams to be the other way so that they're not catching water, or you want some allowances for drainage. But because the roof was detailed in this way, all of the seams, every single seam was catching water, and they were starting to see corrosion at all the seams. So at the time, they estimated the cost to replace this roof to be like $8 million, because this is one of the largest zinc roofs in the world. Zinc normally is supposed to perform for, a very long time, say like 100 years. But if it's not designed or implemented correctly, you're going to run into issues and holes like this, and very costly design repairs or replacement. So had they had a consultant or enclosure engineer involved in the earlier processes, they could have potentially flagged this issue and prevented this costly repair or replacement for this roof. And this is just another photo of the corrosion that our colleague saw. And this is a detail of a bump out of a window that we saw for a project. We weren't engaged in the design processes, but the building owners or constructors had noted that there was some condensation on the windows. And when we looked back at the drawings, we noted that there were things that hadn't been fully considered during the design. We noted there was this kind of dead space where conditioned air wasn't really fully getting into, which is why they were kind of experiencing that condensation on the windows. So had the design team talked together, This really highlights the reason why it's a good idea for the envelope guys and the mechanical guys to be talking together during the design phases, because this is not only a building envelope issue, this is also a mechanical issue. It was important for the conditioned air to get into that space so that we reduce the risks of condensation. Obviously, it's also important to use a higher performing envelope system as well, but the two, again, work hand in hand. And we're just wrapping up here, but I think we've already talked about the commissioning process and what it is, but it's important to recognize that even though it sounds like a daunting process, I know it sounds very costly, I'm sure, as I've described it. It's important to recognize that one size does not fit all. For a simpler project, it's very possible to engage in a much more simpler scope for the commissioning process. You obviously don't need to review every single submittal for a basic brick building with punch windows. You know, it's technology that we understand, fairly straightforward construction, lower risk. And so it's important when owners are developing a scope for the commissioning agent. It's important to review the risks and then tailor the scope for the commissioning process to fit that particular project. So there's no one set scope for the commissioning process. The commissioning process is not going to be $100,000 every time, and it's not going to be $10,000 every time. You can scale it to your needs, basically, as a message. And all those guidelines that I remember that I referenced earlier are exactly that. They are guidelines. Unless you're trying to meet LEED requirements or some established program, you can tailor it however you want. It's basically to fit your needs. That's the message at the end of the day. Use it as you need it. And just to recap, what we've talked about, if there's any takeaways, it's that the building envelope is an important component of the building. It does a lot of that heavy lifting. It highly affects your overall building performance. It's important to recognize there's a difference between enclosure consultants and enclosure commissioners. In the past, there has been some overlap, but they are intended to be separate, but they all fall under this broader category of enclosure engineering. And at the end of the day, the whole idea for enclosure engineering is just to help prevent those costly rework and repairs, and to help manage those challenges in building enclosure design that we talked about. It's important to understand your project complexity. The more complex your project, the higher risk, and perhaps it's a better idea to engage in an enclosure engineer or expert, or somebody who knows that type of technology for those types of projects. And also, it's important to provide a very clear scope. Like if you're trying to request a commissioning agent or enclosure engineer to price a job, it's important to let them know what you want. If you don't let them know what you want, they're going to assume the most basic service, because obviously they're trying to give you the cheapest price. Or maybe on the flip side, if there's nobody competing against them, they just may give you the most expensive price, and they might just give you the full battery of services. It's important to know what you want and talk to them to help develop the scope if you don't know what's applicable for your project. And lastly, it's important to leave it to the professionals. We want people who know what they're doing, who specialize in certain fields, to be doing just that. We don't want the mechanical guys to be doing envelope work. We don't want the envelope guys to be doing fire safety work. We don't want engineers doing architects' work, and vice versa. Everyone's got their own specialty, and they should be doing just that, and they should be working together and talking together to make sure that we work as a team in order to achieve this whole cohesive design and high-performing building. And that's about it. So I'll open up to any questions.